All right, students, we're going to go over your tangents, secants. This is a practice assignment. It looks just like yours, but different numbers. So you can follow right along with here. All this information is also in your DCAS note sheet and everything you should know for your DCAS in your circle section on that. All right, segment PA, remember that's called a tangent. Point outside a circle, it touches one spot on the circle only. And that includes if you were to extend it, it would still only touch one point on the circle. Is called a tangent. And don't forget, a tangent is always at 90 degrees to the center of the circle. So if we want to draw that in there, we'd have a 90-degree perpendicular symbol right there. We don't need that for this problem, but just remember that. All right. And this one is called a secant because it goes through the circle twice at points B and C there. Okay. And so the rule is if we have a tangent, you square the tangent. So that's why you see 6 squared right there. And for a secant, anytime you have a secant, it's the outside length, which we're calling x right here. Okay, x is right there, times the entire length from P to C, which is 14 in the given. They didn't give us PB, so we just call it 6. So remember, anytime it's a tangent, tangent squared. Secant, it's the outside segment, in this case PB, times the whole length P to C. So you get 6 squared equals 14 times 6, 36 equals 14x divided by 14 on both sides. Since they're both even numbers, you must simplify that down to 18/7, and there's your exact answer. All right, number 6 over here. PA is a tangent, it's telling you. So again, that means I can automatically put in my perpendicular symbol. That's why you see that in the green there, to the center of the circle O. Then notice this is not quite a secant because I'd have to go through 2 points after the other point over there. We don't have that. So this technically is not a secant, it's just a segment from P to O. And it says OB is 6. Well, I should recognize OB as a radius. So that means I can put 6 down here for OA. It tells me PB is 6, so I put a 6 there. And it says find PA. Okay. Let's see. So I have 12 there, 6 there. Oh, okay. So notice the hypotenuse, because that's across the right angle, is 12. Hypotenuse equals 12. This one side of the right triangle is 6. So one leg equals 6. Well, if I see that relationship, 6 is half of 12. So that means that 6 side is a 30-degree opposite the 30-degree angle. Because remember, opposite 30-degree angle is always half of the hypotenuse. So this is where we're using our special right triangles again. Okay. To make it simpler, now I could use Pythagorean theorem and have 12 there for my hypotenuse and 6 as one leg, and I call PA, say, x, and do x squared plus 6 squared equals 12 squared, and solve it that way. But I recognize that 6 is half 12, so I mean that 6 side is a 30-degree side, which makes the other angle 6 degrees. And we know the 6-degree side is always root 3 times longer, so it's 6 root 3. And we have that right there, and there's our PA. But you could have gone PA squared, which is called PAX. You have x squared plus 6 squared equals 12 squared using Pythagorean theorem and solve for x, and you would have got 6 root 3 as well. All right, number 2 now. All these are tangents from these points outside. They're tangents to the circle. When you have a tangent to a circle from the same point on the outside, okay, then those tangents are equal. So it says AB, so AB is 12. Where, if AB, where's B? Oh, AB is 28, sorry. AB is 28. AE is 9. So I have 9, and then obviously I go 28 minus 9 to get 19 there. So that puts 19 there and there, because those are tangents from the same point. That puts 9 here and here, because these are tangents to the same point. And it says CF is 12, and so that means this has to be 12. Okay, and then it says find AC now. Obviously AC, we just add these two together. 9 plus 12 is 21. Number 7, if angle C is 60 degrees, so I have that in there, find the angle AOB. Okay, well, don't forget, since this is a tangent from the same point outside, then these two must be congruent right there. And these two are radii, so they must be congruent. So now I have a kite. Okay. We know these are 90-degree angles right here because they're tangents. So I have a 90 is 180, plus the 60 out here is 240, plus the middle angle, which I'm having to solve for, x, I call it right here, equals 360 because it's a quadrilateral. And our quadrilaterals add to 360. Okay, and so x equals 120 degrees. That's how I got the angle AOB. I used that, it's a quadrilateral. I know all tangents to a circle at 90 degrees, and they gave me 60 degrees outside. All right, number 3. Segment PA is a tangent, so I know it's going to be tangent squared. So it's, and they told me PA was 8, so I have 8 squared. Every time it's a tangent, I just square it, the length. PB is 4, so I put a 4 there. Find BC. I don't know what BC is. That's x. Remember, when it's a secant from here to here, it's the outside, which is 4, times the whole length. The whole length is this 4 plus this x. The BC is x. So 4 plus x is the whole length. So now I have 64. And I went ahead and distributed. You could have gone ahead and divided by 4 right away. And then 64 divided by 4 and got 16. Okay. Equaled 4 plus x, and then x equals 12 that way as well. So x is 12, and that's what we were looking for, BC. Number 8 over here, PD and PB are secants. So again, the rule. Okay, so here, we're not talking about the lengths of the secants this time, because then it would be outside times the whole. We're talking about find angle measures. So when I have this, the rule is the outside arc. When I say the outside, that's the one furthest away from angle P right here. The outside minus the inside, meaning the closest one, divided by 2. That's exactly what you see right here. Outside minus inside divided by 2 equals the angle P, which I called x. Now, if you like, and you want to memorize this, outside minus inside equals 2 times angle, in this case P, 2 times the angle measure, because that's the very first step you do is go ahead and cross multiply and get 2x equals 114 minus 31, which is the outside minus the inside. So some people like to memorize the outside minus inside equals 2 times that exterior angle, that angle on the outside there. Or you do outside minus inside divided by 2 equals the angle. Same thing. Okay, your choice on how you want to memorize that. Number 4. These are all tangents, so we know tangents from the same point are equal. So those have to be the same, 23 and 23. We know that these two have to be equal, and one says it's 5y minus 4, the other says y plus 9. So I just set them equal to each other and solve. Okay, and I get y equals 13/4. So that's for y. Okay. FE equals 23 because they have to be the same. So this equals that 23 FA, and so x equals 20 right there. Okay, there's that set up. All right, number 9. We have a tangent and a chord. Remember, a chord is just a segment that touches 2 points on the circle. Okay, connected together there. We treat this as an inscribed angle, where it's half of the intercepted arc. So angle BAC, this angle right here, is 12x plus 7. Arc AEC, let's change the color here. Arc AEC is 34x minus 7, which you see right here. Solve for x. Okay. Well, we know that this arc is double the inscribed angle. So that's why you see double the inscribed angle there of 12x plus 7. That's going to equal this arc. Well, that arc plus this arc, which is 34x x minus 7 has to add to 360, right? It's the full circle now. So I did 360 minus that 34x minus 7 has to equal the other arc right there, double the inscribed angle. So you could have had this added to this side over here, and then these two arcs together equals 360 if you want to set up that way as well. It's the same thing. Okay, then I distributed, it's just algebra 1 skills the rest of the way. And it actually goes 329 over 58. Okay, exact answer. Doesn't say to round it, put it in decimal. All right, number 10 now. Angle DEF, that's this thing right here, is 4x minus 8. Remember, this is going to equal half of its intercepted arc. So if I double that angle, 4x minus 8, double that, it has to equal that arc. Okay, or I take the arc and take half of it. Okay, either way. So in what I did over here, I took half of it instead, and then I had to double both. I could have gone ahead and just made it 117 equals 2 times 4x minus 8. That would have been easier. Okay, but either way works. Distribute through, and you get your 8x minus 16 right there equals the 117, and then you finish off with 133 over 8. Okay, over here now, again, we have a tangent and a secant, but we're talking about arc measures again. So it's the outer minus the inner equals double that angle. Or I can say outer minus inner divided by 2 equals the angle. But let's go ahead and, which is what I did down here, outer minus inner divided by 2 equals the angle. Okay, and I have it filled in right here. First step I did is multiply the whole equation by 2. So again, these two cancel out here, but then I'm distributing the 2 over here, and I get the 10x plus 12. Okay, add the 15x across, 25x, subtract the 12 across, 183. Last step, divided by 25 on both sides. All right, back side now. Some more practice. Again, I get practice with this. Arc BD and angle P. So this time they give you 2 other pieces. Remember, it's the outside arc minus the inside arc equals double the angle, or outside arc minus inside arc divided by 2 equals the angle. So again, I'm doing the divided by 2. Okay, as you see there, but if I want to do outside arc minus inside arc, call it x, equals double the angle, 34. Same thing. So add the x across, subtract the 34 across, make it x equals 140. Okay, whichever way you prefer. Since I've done it one way already written out here, I'll do it the other way for those that prefer that. You have to be able to tell me one or the other. You better be able to tell me anytime I ask you for finding the angle outside minus inside equals double the angle, or outside minus inside divided by 2 equals the angle. Got to have it memorized. All right, and again, these are all in your decaf sheet. All right, here we go back to lengths of tangents and secants. Remember, anytime it's a tangent, I square it. So that's why you see x squared there. Anytime it's a secant, it's the outside times the whole right there. So 9 times 25. It's not 9 times 16. That's a common error students make. It's not. I've never said outside times the inside. I said outside times the whole. So 9 times 25. Okay, I can multiply that out, or I could have ended up taking the square root of both of those. 3 times 5 is 15 also. I would have square root of both of those right away. Okay. Number 12 now. Again, we have a tangent and a secant, more practice. The tangent is always squared. That's why you have x squared. The secant is the outside 4 times the whole. The whole, as it says, PC is x plus 12. Now I go ahead and distribute that. Notice I end up with a quadratic. The first thing I do with all quadratics is set equal to 0. The x squared is positive on the left side, so I move everything to the left side. I get x squared minus 4x minus 48 equals 0. And now I go ahead, that does not factor. Okay. Now I go ahead and plug in my graphing calculator and find the zeros or the roots or the x-intercepts or solutions, all call the same thing. or I can plug in the quadratic formula. Remember, on the DCAS, they will give you the quadratic formula. Again, for Algebra 2, you should memorize it. Those going on to Algebra 2. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And so we solve that, and the approximate answer is 9.21. So round to the nearest hundredth. I didn't put that on the worksheet, but you see it from the video here. All right, 16. Again, we have a tangent. No, we have two secants in this case. Notice two secants, not a tangent, a secant, two secants. Okay, so I have AE is 4, AB is 13, and AD is 5. So if that's 5, that's 13, that makes this piece 8 right there. Okay, now we have 4 here, and for this whole length, remember, this is a radius, isn't it? From there, there's a radius. If I call it x, and that x for the radii. Okay, and the reason I'm choosing to do that is because it wants me to find just OC, which is just the radius. Okay, if I called ECX, then that's the diameter. I have to remember to divide by 2 at the end. Okay, so I'm looking for OC, the radius, x there, x there. Okay, so again, it's the secant, so it's the outside, 5 times the whole, 13. That's for this one. And the outside here is 4 times the whole, would be 4 plus, I could have said 2x, or d. So I did that one over here. 65 times equals 4 times 4 plus 2x. This one I used one single letter of diameter. On this one here, this one I broke it into 2 radii. Your choice. You end up getting the same answer. Okay. So you can finish off the algebra skills from there. Here's your quadratic formula. Okay, that I spouted off just a second ago for the above problem. Here, we have a tangent and secant again. So the tangent squared equals the outside 5 times the whole, 5 plus x. Go ahead and solve it. 17, the ratio of the arcs. Remember, ratio, whenever I see this ratio like here, I automatically put an x behind each one of these. The ratio of the arcs of AB, this arc, that's 2x. BC, this arc, that's 4x. And AC, this arc, is 6x. Well, doesn't that cover the entire circle? So all those add together, the entire circle is 360 degrees. So I add them all together, I get 12x equals 360, x equals 30 degrees. So x is 30. So now I can go ahead and fill those in. Okay, remember, this first one, AB, was 2x. 2 times 30 is 60. AC, which is the last one, is 6x. 6 times 30 is 180. And I didn't have to write this one there, but I went ahead and did it. Just for your sake, I just needed those two, because remember, it's the outside minus the inside. 180 minus 60 divided by 2 equals the angle itself, or I could have said 180 minus outside minus inside equals 2 times angle P. So you get 120 equals 2 times the measure of angle P divided by 2, and you get measure of angle P equals 60 also. Okay, same thing. All right, 14 and 18, the last two. Okay, we're back to a right triangle because we have a tangent. Remember, PO is not a secant because it doesn't go all the way to the other end. Okay, it only goes to center, so we just have a right triangle. Oops, right triangle there, because all tangents are 90 degrees to center. Again, this is a radius and this is a radius, so they're the same right there. OA and OB are both radii. So I just call those x. And it says BP is 9. So now I have Pythagorean theorem. X squared plus 15 squared, the two legs, sum of the two legs squared, equals the hypotenuse. That hypotenuse is x plus 9 quantity squared. So now I got to remember my algebraic skills for squaring a binomial. When I square a binomial, I square the first term, so x times x is x squared. I multiply the two together, 9 times x is 9x, and double that to give a middle term of 18x. And then I square the last term, 9 squared is 81. So I have a quadratic on this side, and I have a quadratic on this side. Well, now the x squares are going to cancel each other out. Let's subtract the 81 across. I get 18x equals 144. X equals 8. Okay, and it said to solve for x, so I'm done. Always go back and read the question. All right, last. PA and PB are tangents. So again, this has to equal this if we're talking about lengthwise. Okay, but we're not talking about that. It says find angle P again. So again, arc AB is 104. Notice that's 104. They don't tell me what the other is. But the other, ACB, is not the rest of the entire circle. So I can get that one by doing 360 minus that 104. And that gives me 256 for this one. So now I do have those two arcs, which is what I need. Outside minus the inside divided by 2 equals the measure of the angle. Or I could have gone outside minus inside equals double the measure of angle P. Okay, and then I have 152 equals 2 times the measure of angle P, and divide by 2, and I get 76 that way. Same thing. All right, that goes ahead and ends it.